So hello everybody. So welcome to this talk about deploy Odoo with Kubernetes. So yeah, first off, if you have some questions during the presentation, you can put them directly on the pad of the mirror room, which is available on the link that you can find on the screen. First, yes, a short introduction about myself. So my name is Adrien Peiffer, I'm 32. I'm project and technical lead at ACSONE, and I'm Odoo developer since version 7. That's enough about me. So the summary of this presentation. So first, we'll take a look at how Kubernetes works and what is Kubernetes, to help us to understand this presentation as well as possible. And then we will look at the situation in which Kubernetes can be beneficial for Odoo deployment, or where Kubernetes may not be the appropriate solution for deploying Odoo. And finally, the most interesting part of this presentation, only my opinion, will be how to deploy Odoo on a Kubernetes cluster. What are the various components that make it possible? And we will deploy Odoo together on a local Kubernetes cluster. That was for the summary. So let's move on to the next part of this presentation about what is Kubernetes. And before Kubernetes, we have the concept of containerization. So what is containerization? Basically, it's very simple. So containerized applications are applications that runs in an isolated runtime environment called containers. And those containers encapsulate an application with all its dependencies. So on the screen, you have the example of the Odoo image. So there is an official Odoo image, which is available on the Docker Hub. And this image encapsulate the Odoo application itself and some dependencies. I say some because the PostgreSQL server, for example, it's not included in the image. But all other dependencies are included, like WK-HTML, Node, npm-less, and so on. And the advantages of the containerization are numerous. The most important being its portability. So with this kind of thing, it's very easy to move an image from an environment to another one. And its speed of deployment as well. This is for the basic understanding of what is containerization. So now move on about what is Kubernetes. Here, the definition of Kubernetes itself from kubernetes.io. So Kubernetes is a portable, extensible open source platform for managing it's quite difficult to say, containerized workloads and services that facilitates both declarative configuration and automation. So this is very simple, but there is some important keywords that we will discuss during this presentation. And now, if we take a diagram to illustrate that, in fact, it's not very complicated. It's just a matter of containers running inside pods. Pods is just a logical Kubernetes entity. And those pods runs on nodes, which can be a virtual machine, for example. So it's just some kind of logical component that will allow Kubernetes to deploy a container on a node. And those pods runs in the context of a namespace. Some pods can be accessed from outside the cluster using services and ingresses. That was for the basic understanding of what Kubernetes is. So let's move on to the next part of this presentation. Why or why not? I will start with a disclaimer. It's just my personal opinion. So I don't want to say you have to deploy Odoo with Kubernetes for that or that reason, or you have not because of that or that. At the end of the day, it remains a matter of taste and a matter of affinity you have with Kubernetes, with the containerization and so on. And at the end of the day, which is very important to evaluate the return on investment. First, why not? In case of a single environment or a single Odoo instance, Kubernetes may not be the most appropriate solution, at least in terms of setup cost. Because the learning curve may be too high if you don't need, for example, high availability. We will talk about high availability later. But if it's possible for you to wait a certain amount of time to have Odoo running after a disaster, for example, it's not a problem. In this case, Odoo Kubernetes may be not the most appropriate solution. Another important point is there is some tools to set up alongside a Kubernetes cluster. For example, the logs, you can access the logs during the run of a pod. But if you want to consult the history of the logs, you have to put in place something to grab and to access log. And for sure, this is represent a setup and a maintenance cost. And finally, this is something to learn. So even it's not that terrible, we will see together, we will see all files that make it possible to deploy Odoo very easily on a Kubernetes cluster, but you have to learn. So if you don't have time to learn, it's a matter of priority, but if you don't have time, perhaps this is not the appropriate choice. That's for the why not part. And now, why? For those reasons, more or less. If we need, for example, high availability, or if we need to have a low RTO, recovery time objective, in terms of resiliency. We have with Kubernetes self-healing mechanism that enable us to redeploy an application if something went wrong on a node, for example. So if we have a crash on a node, Kubernetes will try to reschedule the pod, the container, on another node. Another point is, if you have a large number of environments, it's possible to have fairly grained security level. So for example, if you want to give access to that environment or to that person or that team, it's totally possible without giving the full access to the cluster. Another point is, with Kubernetes, everything is deployed using manifest, so written in file, in fact. So everything is written on file, on manifest, and so we can publish those files on a source control. In addition to that, it can be easily deployed using CI/CD tools. As everything is written, if you have a CI/CD tools that can access to this file and have access to the cluster, everything can be done automatically by the CI/CD tool. And finally, last but not least, it's totally portable. It means today, we will deploy Odoo on my local machine on a Kubernetes cluster. Tomorrow, we can deploy it on a Kubernetes distribution that we can install on bare metal server, for example, or we can deploy it tomorrow on managed services like Azure AKS or AWS EKS, for example. That's for the second part of this presentation. And yeah, at the end of the day, always evaluate the return of investment. And now, the most interesting part of this presentation. How to deploy Odoo with Kubernetes. Is it so terrible? We will answer the question after. We need some components to deploy Odoo on a Kubernetes cluster. As I said, Kubernetes will schedule Odoo pods, so the Odoo container provided by the official image of Odoo, on nodes. So if something went wrong on the node, Kubernetes will reschedule the pod, will reschedule Odoo on another machine. So it's okay for the image itself. But one important thing is we have to keep the access to the data. So basically with Odoo, we have three kinds of data. The data from the database, from PostgreSQL. We have the data for the attachments that are stored on the file system normally. And we have the session users that are stored also on the file system. And we have to keep those data. So if something went wrong on the node, we have to be sure that we will access the attachment, the session, and the PostgreSQL data on another node, for example. So for that, we need some component. So first, for PostgreSQL data, we will use Cloud Native PG, which is a Kubernetes operator that offers a primary standby architecture using the native PostgreSQL replication. This is an operator which is developed by Enterprise DB. And so with that, data can be stored on the node. If we set up the replication, if something went wrong on the node, we have a replication somewhere. 1, 2, 3, 4, and so on. For the attachment, we will use OCA FS attachment add-on based on FS spec. This allows attachment to be sent to various storage systems like S3 compatible storage, for example, or Azure file, and many others. For the session, thanks to the OCA session DB add-on, that gives us the possibility to store the session of the users directly in the database. So we solve this issue like that. With all those components, we are ready to deploy Odoo on a Kubernetes cluster. And now take a look at an architecture diagram of an Odoo deployment in a Kubernetes cluster. So it's all components from Kubernetes. So first, we need a deployment. A deployment will ensure with the replica set that we have the number of replica needed for Odoo. So basically, it will ensure that you have Odoo running somewhere. So we have Odoo running, the container running inside the pod, and the container can be accessed using services internally to the cluster, and the ingresses, such kind of reverse proxy, to access Odoo outside the cluster. What else? We need PostgreSQL, which will run into a pod as well. And we need a persistent volume somewhere to store the data, basically on the disk of the node in this example. And now, let's deploy Odoo on a Kubernetes cluster, and let's take a look on what are the manifests that will allow us to deploy Odoo on a Kubernetes cluster. Yes. So, everything starts from a Docker file. We cannot use the image provided by Odoo like that because, as I said, we need additional modules. SessionDB, FS attachment. So we will build our own Odoo image, but with no more change. So we build a Docker image from the official image of Odoo, and we will use a requirement.in that contains add-on that we see before, which is basically Odoo add-ons FS attachment and Odoo add-ons SessionDB. And we will install it with pip install thanks to PyPI in which those modules are published. And we will copy an additional script which basically is responsible to initialize the database if it's not yet initialized. It's enough. So we have an Odoo image. At this step, we have an Odoo image to deploy on a Kubernetes cluster. Now, let's take a look on the manifest on the file to create the resources inside the Kubernetes cluster. So first, let's take a look on the PostgreSQL one. This is the YAML file to deploy a PostgreSQL cluster using Cloud Native PG on a Kubernetes cluster. It's a custom resource definition, so it's provided by CNPG. So we will create a resource on of-kind cluster. We give the name of Postgres. And during the bootstrapping of the PostgreSQL cluster, we want to initialize a database. So basically to create an empty database. With the name of Odoo, owner Odoo, and we can add some additional steps. So we will create a database, which is SessionDB, to store the session of the users. and we add an additional permission to Odoo users to allow it to create database. We enable the super user access, so by default when we set up when we bootstrap a PostgreSQL cluster with Cloud Native PG, the super user access is disabled, but it could be useful, for example, for PG activity to have it enabled. As we will deploy a container, we need an image. So we will use the image of PostgreSQL 16 provided by Cloud Native PG. Just for the demo, I will not push the image, it's downloaded locally on my machine to avoid some network issue. We need one instance of PostgreSQL. So basically no replication, just one primary PostgreSQL in this example. And we can add some additional PostgreSQL parameter that will be pushed on the PostgreSQL configuration. That's all we need to set up a PostgreSQL on a Kubernetes cluster with Cloud Native PG. Now we have to deploy Odoo. So let's take a look first on the deployment resource. So we need to create a deployment that will be responsible to maintain the Odoo pod. With the name of Odoo, one instance of this pod, some match label in order to make the link between the pod and the deployment. When we will push the deployment, the pod will be recreated in this case. And we add the template, so the specification of the pod. So first you add a label to make the link with the deployment and to be able to identify by automated process, for example. We can add some affinity. It's a very interesting concept. So basically, in this case, during the scheduling, I want to deploy Odoo in the same region in which there is a pod, a PostgreSQL pod, which is primary. So we want to deploy Odoo in the same region. After that, we have an init container. Init container is basically something which runs and be completed before the starting of the real container. Basically, in this case, it's just to run the script to initialize the database, if it's not yet initialized, for sure. So, yes, so the Odoo init for the name of this init container. We will use the image which is built with the Docker file that we see before. Same thing for image pool policy, never for this demo to avoid to download it from internet. And we run the script that we see before. And we can define some environment variable for this container. So basically, we define PG user, which is useful for PostgreSQL client to access to the database. And this value, this user will come from a secret automatically created by the CNPG cluster, so which is Postgres app in this way. We need to define Postgres user variable, which is exactly the same, because Postgres user is needed by the Odoo official image. Same for PG password and Postgres password as well. And we can define some other environment variables. That comes from a config map. This is another Kubernetes resource. In this config map, we can find, for example, dbhost, which is used for Odoo itself. And we use Postgres RW here. Basically, this is a service automatically provided by CNPG. DB port, this one is used for the Odoo official image, PostgreSQL client as well, and the session DB URI for the connection with the database that manages the session. Let's go back to the deployment now. So we have after the container in which Odoo will run on. We use the same image, same thing for image policy. We will use the same environment from the init container. It's exactly the same value. That's a YAML syntax that allows us to reuse the previous part. And we define here some limit and requests that are concepts for managing resources by Kubernetes, just to avoid to have warning in my presentation here. And we expose some ports, which are the ports that you probably know. In addition to that, we add a readiness probe to be sure Odoo is properly running on the port. That's for the deployment. So after that, we will be able to see that we have a pod running inside a Kubernetes cluster with Odoo inside. But we need to expose those ports. First, internally inside the cluster. For that, we need a very simple service of type cluster IP. Basically, this service will expose the Odoo port inside the cluster. After that, to expose Odoo outside the cluster, we will use ingress. So we need an ingress configuration to expose the port from the service to a local URL. That's all. That's all we need to deploy Odoo on a Kubernetes cluster. This is a very generic configuration. There is no black magic inside, no custom tool. There is just Kubernetes and the official Odoo image that we tune to add some add-ons. And now, we will deploy Odoo on a Kubernetes cluster. We will apply those files. So we have an empty Kubernetes cluster. This is K9, which is a tool to browse Kubernetes resource. And so we have nothing. Does someone have an idea of the amount of time to deploy PostgreSQL, Odoo, and to have it running and to browse this URL in my local Kubernetes cluster?
1 minute.
Quite optimistic. Anyone else? But okay, it's fair. 1 minute. So let's start. I will apply all file in one time just to avoid to make multiple type the command. So I use a customization file in this case that have a summary of the file, and I will apply them. So let's take a look. All is applied. PostgreSQL initialization in progress. PostgreSQL initialization done. So PostgreSQL is starting. PostgreSQL is started. Odoo is running. So the initialization of Odoo is running. If we take a look on the logs, initialization in progress. Initialization is done. Odoo is running. Everything is good. So less than 40 seconds to deploy Odoo on a Kubernetes cluster. Let's take a look if we can access to it. Okay, less than 40 seconds to deploy Odoo on a Kubernetes cluster. Questions? I think I will just check if there is some question on the pad from the broadcasting. I think there is no. If someone can give the mic to...
Hello.
Yeah.
First of all, great presentation.
Thank you.
I have many questions. Let's start with one, and then if there are some more, I keep going. First, do you find any benefits with cloud native PG versus just a PG?
With cloud native PG, so the question is if we take any benefits from cloud native PG?
Yeah,
it's a very great tool and very well maintained.
Okay.
So cloud native PG takes care of to set up the native PostgreSQL replication. It's not a custom replication. It will take care of set up the PostgreSQL replication It will take care of the backups. We're using Barman, which is developed by Enterprise DB as well. So yeah, it's a very great tool and very well maintained. Usually when we find a bug in Cloud Native PG, it's already fixed.
Okay, great. Are you using, because we make some similar deployment, but we are using Postgres with our own deployment just manually, like, and implemented backups also separately. But we have some use cases like duplicating big databases, point-in-time recovery, all that. We don't have it covered. Is it covered on Cloud Native PG? Do you know?
To restore the database?
For example, to duplicate a database, but a heavy one with load, you can call some command to backup, restore.
In fact, on the bootstrapping of the PostgreSQL Cloud Native PG, you can specify that you want to make the bootstrap from a backup, basically.
Okay.
So that's how we do for when we have to restore some environment from production to another environment for UAT and so on. We use the backup, so we bootstrap from the backup, basically. So it's we just to have applied the same resource that we see before, but in the bootstrap section, instead of having initDB, we have recovery, basically, and you have the link to the storage in which we can find the backup.
Perfect. I have some more, but...
I was just wondering if you guys experimented with horizontal auto-scaling with this specific setup, and how well does Odoo handle that type of scaling in that environment?
No, we don't use auto-scaling for our needs. Sorry.
I have one question about the session store in the database.
Yeah.
So you already connected a volume. Why you don't store it there? Is there a performance reason about it?
I'm not sure to understand the question. I will. I forgot the mic.
So my question is, you store the session in a database,
yeah,
but you have already a shared volume. My question is, why you don't use this volume for the sessions? Is it a performance reason or?
No. Basically, another way is to set up those kind of distributed storage. In this way, the storage is not distributed.
Yeah, but
so
we have
a local storage on the nodes in which we have the PostgreSQL data. And the replication is done by the PostgreSQL replication. So it's not done by a distributed file system. So we don't have, in this kind of example, we don't have any distributed file system. The data are stored on the nodes, and the synchronization is done by PostgreSQL native replication.
Okay, but the file store you need to synchronize either, because when you save PDFs or something like that.
For the file store, we use FS attachment add-on that allow us to push the attachment not on the file system, but in various storage as S3 compatible storage, for example.
Ah, okay. That I missed.
So there is nothing, there is no distributed file system in this example.
Okay, and
attachments are accessed and pushed to various storage systems using FS attachment add-on.
And the cloud storage is too slow for storage.
Yeah, true.
Yeah.
And the another question is how I can update the database. So when I have a cluster with 3 or more bots, and I want to update it or publish an update, how it works?
To update the add-ons?
Yes.
Okay. So for that, there is multiple possibility. So at ACSONE, we use a tool which is click Odoo update that allows us to compute a hash of add-ons directly on the database. And if we detect any change during the initialization of the database, those add-ons will be updated automatically. There is other solution, but that's the way we do that at ACSONE.
Do we tear down all bots during the update? That means that
it's quite difficult to keep Odoo running during the upgrade. It's possible to try it. It depends on the amount of the add-on you have to upgrade. Because if you have a concurrent update during the transaction, the update will start from the beginning.
Okay. Thank you very much.
You're welcome.
Great.
Thank you.
So you said you don't use the dynamic scaling.
Yeah.
So what is good in Kubernetes you use that you will be hard to achieve with traditional tools?
Basically, if you have something in this kind of architecture, if you have the first is the high availability. So if there's something wrong on the nodes, so we have Odoo that will be rescheduled automatically on another node, and there is Cloud Native PG that will take care of make the switch between the primary and the replica, for example. So you have nothing to do. If you have a crash on a machine, Odoo will be rescheduled, so the Odoo image will be rescheduled on another node, and you have Cloud Native PG that will make the switch over from the primary to the replica.
And
this is one advantage.
Yes, for instance, during the year, how many time did it happen in your?
How many time too?
How many time you had this failover thing to
it's
take place?
Totally configurable.
No, but I mean during the year, did failover happen?
Perhaps one time a year.
One time a year.
That we have a disk failure on a machine, for example.
It gives also flexibility to manage your fleet of nodes. It's very easy to add new nodes on different machines and move the workloads from one node to the other. For instance, when you do a big an OS upgrade on a machine or something like that, gives lots of flexibility. And also, I should say that Cloud Native PG, for us, that would be if only one reason to use Kubernetes, because Cloud Native PG is so easy to use to manage Postgres with one Postgres cluster per environment, with the point-in-time recovery and so on. It's much more easier than to manage your Postgres yourself. That's clear.
When you are using one Postgres instance per Odoo container, it's like the link is one-to-one.
Yes, this is the architecture that we put in place.
Perfect. And do you use that for small customers? What we do actually is we have one Odoo instance per database, but the Postgres is shared, so that the resources of the Postgres are shared. So we have like, I don't know, 100 databases, production databases, staging databases, and so on one Postgres. But yeah, we think on this on going one-to-one, but we don't know if the resources are going to...
Yeah, this is the only thing. That was we had this kind of architecture before switching on Kubernetes. And yes, this is if you install Kubernetes distribution on a bare metal server, for example, this is the only cost you have additionally, because yes, you need basically more RAM because you have one PostgreSQL per environment.
Yeah, you can still play with the limits and the reservation, and you can,
But then you gain point-in-time recovery, easier Postgres upgrade, because if you have a big Postgres cluster, you need to put all your customers down at the same time when you upgrade and stuff like that. So it's much more flexible. It costs a little bit more resource, but
that's an issue for us, because when we have, I don't know, 50 production database on one Postgres server, then they they move to a newer Postgres, newer version, and then you need to deal with that. I need to downgrade this Postgres because I only have 10 customers there. So yeah, it's a great win there.
Any other questions?
Okay.
Next one.
Okay. For storage, we are using the S3 camp-to-camp approach. I don't know if you are aware of those modules. They were before, I believe, OCA S3 modules.
So before the creation, I think by Laurent from FS Attachment, we was using the add-ons by Camp to Camp. Just the FS Attachment, which I think it was done by this module.
Now so the question will be, now you're using the OCA add-ons, the ones that are on the OCA, and well, what we have with the S3 approach is sometimes it is not really fast to get the attachments. So The approach in Come2Come with the Come2Come add-ons is that it depends on the rules you define. Some of the binaries are stored on the Postgres database, so that small files are...
This is exactly the same for FS attachment. Just the advantage of FS attachment, we can define multiple storage, and we can define multiple rules by storage, in fact.
Okay.
So we have so with the same add-ons, we can use Azure storage, for example, or S3 storage.
I think you contributed several PRs to the Come2Come S3 modules, but they were not merged, I think, and I understand that Come2Come does not maintain it anymore. And basically all the features you contributed to the S3 module of Come2Come, they are now in the FS attachment, FS storage. So the different environment per config per environment, so on. Okay. Everything is there. Yeah.
Right.
Next question.
Please. Thank you. Regarding sessions being stored on Redis or Postgres, because you are using now Odoo supports sessions on Postgres out of the box. Yeah, I don't remember. We store sessions on Redis. But I believe I have seen some module in Odoo on the Odoo repo that implements storing sessions in Postgres. You store sessions in Postgres by a module, another module of SessionDB. Okay. Okay, I will check that. And so for each Odoo database, you have an Odoo Postgres database for sessions.
Yes.
Each 2 database per instance, Odoo instance. Okay, perfect.
This SessionDB module was initially done by Nicolas Saint-Lay at Odoo, I don't know, 5 or 6 years ago. And I picked it up, and we have improved it to make it much more stable. And the reason we don't use Redis is that it's just because it's simpler. We have one less moving part in the architecture, and honestly we have not done performance comparison between SessionDB and Redis, but honestly it's fine. It's a very simple table indexed on the session ID, no transactions, so it's very fast in Postgres. So.
And last one will be and last one before the lunch.
One last question. Do you happen to, if you have, for instance, QJob, the job runner, do you run it from the same pod as Odoo frontend, or
up to
you create different pods?
It's up to you. In our architecture, we put it in the dedicated pod, so we can maintain resources. But because we have the fact which is very interesting here, it's we have by Odoo process, we have the possibility to define the limits, so the memory limits and so on. And so here in our architecture, we put the Odoo jobs in a dedicated pod, in a dedicated deployment. One advantage of that is to configure those parameters only for the jobs. If you have to stop jobs for something, there is just jobs that are stopped, and Odoo Interactive is keep running.
And when you update Odoo, you shut down both pods for running the update?
Yeah.
Okay, thank you.
One short question would be, which ingress are you using?
Which ingress classes?
Ingress.
Nginx.
Nginx, okay. And we have been playing a little bit with Knative. I don't know if you see that one. It allows you to define, it deploys the ingress by itself, and you can define quite easy some auto-scale rules, so that it depends on the requests per second you get. For example, more pods are being created, and the ingress also, if it can go till 0 pods, if no requests, for example, for a testing database, when no requests are received, it can go to 0, and then if a new request comes, it stops the request till he wakes up the pod, and then it delivers. We have been playing with that, but for that, with auto-pod scale and so on, we believe that multi-process would not be ideal, because it would be more like a multi-thread deployment of Odoo would be more logical, but we face other challenges there. I don't know if you have played with that, if you have any plan.
No.
Yeah. Okay.
So one question, because you were talking about like a separate pod running scheduled tasks and everything. So in that case, I assume Cloud Native PG out of the box handle several writing nodes for that database? Or okay, you know there.
I didn't catch it, but I didn't catch the question.
So the question is, I understood from an earlier question that you have a pod dedicated to scheduled task and that sort of stuff.
Yes.
In that case, since you're running kind of a one-to-one Odoo instance to Cloud Native PG inside your dedicated pods.
No. Yeah.
Okay, I misunderstood that.
This is the same connection. But there is an interesting thing. I don't know if you remember, but last year during the keynote, Anthony Le Suisse talked about the fact to have, in future version, to have the possibility to connect to read-only PostgreSQL. If, for example, for the read access, so if you have to read something in Odoo by using the ORM, Odoo will be able, in future version, to target a PostgreSQL replicate. And with Cloud Native PG, everything is ready for that. So Cloud Native PG provides a read-write service and a read-only service, which, if we have replication, we can use this service.
And actually, this feature is available in 18. I've prepared the Odoo Bedrock image, and there are new configurations. So you have the main Odoo connection and a replica Odoo connection where you can give the host and port for the read-only replica. And so for that, in Cloud Native PG, you can say, okay, I have one primary, I want three replica, and you can distribute all the read-only workloads to many replica. It's trivial to do. Never tested 18 for that, but we'll see.
Thank you. Time to lunch. Thank you very much.